Dear student, in the earlier video we learned the Cauchy-Riemann equation in Cartesian form, Cauchy-Riemann equation in polar form. In this video we solve the examples on that. The first one is find the derivative of analytic function. Let us know the working procedure. Step 1, given w is equal to f of z, they have given function. We substitute z is equal to x plus iy or z is equal to r into e raised to I theta to find the real and imaginary part of u and v as a function of x, y or r comma theta. So depending on the function we put z value x plus iy or r into a raised to I theta, then separate the real and imaginary part. Then step 2 is we first find first order partial derivative, that is dou by dou x, dou by dou y, dou v by dou x, dou v by dou y. Similarly in the polar, dou by dou r, dou by dou theta, dou v by dou r, dou by dou theta. And verify Cauchy-Riemann equation in the Cartesian or polar form to conclude that f of z is analytic. Then the third step is to find the derivative of f of z. We make use of fundamental result derived while establishing the CR equation. Means we use the condition of CR equation. They are as follow. If it is in the CR equation Cartesian form is there, then we use the f dash of z is equal to ux plus I into vx. If it is in the polar form, we use f dash of z is equal to e raised to minus I theta into ur plus I into vr. So to find the derivative, we use this f dash of z in terms of Cartesian and in terms of polar form. Then fourth step is we substitute the partial derivative and rearrange the function as a x plus iy or r into e raised to I theta, which represent a z, with the result of f dash of z is obtained as a function of z. Means we put the partial derivative and rearrange the function of x plus iy or r into e raised to I theta, which gives a z, with the result f dash of z is obtained as a function of z. By substituting, we obtain the f dash of z in terms of z. So the working procedure is, first they given in terms of w is equal to f of z, depending on the function we put z is equal to x plus iy or r into e raised to I theta, then separate real and imaginary part. Then we find the first order partial derivative depending on the Cartesian and polar form, then verify the Cauchy-Riemann equation, then conclude that f of z is analytic. Then to find the derivative, we use the formula f dash of z is equal to ux plus I into vx in Cartesian form, f dash of z is equal to e raised to minus I theta into ur plus I into vr in polar form. Then last step is put all the value, that is partial derivative, and rearrange the function, then obtain the function, that is f dash of z is equal to in terms of z. So that is a derivative of f dash of z. So by using this procedure, let us solve the example. Show that w is equal to z plus e raised to z is analytic, and hence find dou w by dou z. So first we show that it is analytic, then find the dou w by dou z. So here given that w is equal to z plus e raised to z, first step is put w is equal to u plus iv, then z is equal to x plus iy. So here put z is equal to x plus iy and w is equal to u plus iv, we get u plus iv is equal to x plus iy plus e raised to x plus iy. Then simplify this x plus iy as it is, plus it is in the form of a raised to m plus n, a raised to m into a raised to n, that is e raised to x into e raised to iy. Then on simplification, u plus iv is equal to x plus iy plus e raised to x, it is in the form of e raised to I theta cos theta plus I sin theta, so that is cos y plus I sin y. Then Here, separate the real and imaginary part from this. U plus iv is equal to x in it is real part. Then here real part is e raised to x into cos y. So x plus e raised to x cos y is real part plus imaginary part is the coefficient of y, I. So that is I plus e raised to x sin y. So it is a imaginary part. So first we return the w is equal to z plus e raised to z, then put w is equal to u plus iv, then z is equal to x plus iy, then simplify, separate the real part and imaginary part. We get u is equal to x plus e raised to x cos y real part, v is equal to y plus e raised to x sin y. Then we find the partial derivative, means differentiate u with respect to x and y, v with respect to x and y partially. So differentiate u partially with respect to x and y, we get differential of x is 1 plus cos y is constant, e raised to x differential is e raised to x. So similar differential with respect to y, differential of y this will be 0, e raised to x as it is, differential of cos y will be minus 5. Similarly for v, differentiate v partial with respect to x and y, we get dou v by dou x equal to differential with respect to x means it will be 0, e raised to x differential e raised to x sin y is constant. So similarly differential with respect to y, dou v by dou y differential is 1, e raised to x as it is, sin y differential will be the cos y. Then we have to check whether it is analytic or not. So by using Cauchy-Riemann equation, we have to prove. Therefore, Cauchy-Riemann equation is in the Cartesian form is dou v by dou x is equal to dou v by dou y and dou v by dou x equal to minus dou v by dou y. If these two conditions are satisfied, then the W is analytic. So let us see. So dou v by dou x equal to dou v by dou y. So both answer will be 1 plus e raised to x cos y, 1 plus e raised to x cos y. So it will be condition obey. Then second one is dou v by dou x equal to minus dou v by dou y. It is dou v by dou x value is e raised to x cos y, dou v by dou y value is minus of e raised to x sin y. So it is also both are equal. Therefore these two conditions satisfied. Therefore W is equal to z plus e raised to z is analytic. This is first part. Then in the question they ask the that is derivative. Derivative means find dw by dz, dw by dz or f dash of z. So here we have solved in Cartesian form. So in the third step I have given if it is Cartesian form, then f dash of z can be taken as ux plus I into vx. So ux means dou u by dou x, vx means dou v by dou x. So already have calculated dou v by dou x and dou v by dou x. Take these two value and simplify. So here dou u by dou x means 1 plus e raised to x cos y plus I into e raised to x sin y. So next is after substituting only simplify, so and rearrange such that the function is in terms of z. So here 1 plus e raised to x cos y plus I into e raised to x sin y is there. From these two we have taken e raised to x common, the remaining is cos y plus I sin y. Then cos y plus I sin y can be written as e raised to I theta, in place of theta y is there. Then it is the form of a raised to m, a raised to n, it can be written as e raised to x plus iy. Then we know that x plus iy means z. So 1 plus e raised to z. Therefore dou w by dou z equal to 1 plus e raised to z. The derivative of f of z is 1 plus e raised to z. So this is a procedure to solve the function, the function is analytic and find the dou w by dou z. Then here we have taken x plus iy, because if you take r into e raised to I theta, the calculation will be lengthy. So in the working procedure I have mentioned, depending on the z value we take the whether z is equal to Cartesian form or polar form. Here z, if you take r into e raised to I theta, then the calculation will be lengthy.